Hey guys, this is going to be the first of our video notes. I haven't done this before, so let's see how it goes. Okay, objectives for today. We're going to be able to sketch graphs showing key features of exponential functions. We're also going to write exponential functions using tables and graphs, and we're going to compare linear and exponential functions. So this is 6-2 exponential functions. We just wrapped up all the rules of exponents, so let's move on to how this looks on a graph. So first example, we're going to look at the equation y equals 2 to the x, okay, or f of x equals 2 to the x. Remember, f of x is just the same thing as y equals, okay? So the big thing to notice here is that our x, okay, our variable, is in the exponent. That is why this is called an exponential equation. So let's fill out the table together. Let's figure out what each of these give us. Okay, so y equals 2 to the x. So the first problem we're going to try and figure out is y equals 2 to the negative 2. Now remember, we don't like negative exponents. Negative exponents are reciprocals, so that gets moved to the bottom. This turns into 1 over 2 squared, which is the same thing as 1 over 4. So our first point will be negative 2, comma 1/4. Okay, now we're going to do it with negative 1, 2 to the negative first, same thing as 1 over 2 to the first. 2 to the first is just 2. So we get 1/2. Okay, let's plug in 0, 2 to the 0. Remember, anything to the 0 power is 1. So we get the point 0, comma 1. Okay, plug in 1, 2 to the first. That's just 2. And finally, 2 squared, that just equals 4. So now that I have my list of values, I can go ahead and plot these points. So the first point I'm going to plot is negative 2, 1/4. So I start at the origin, negative 2, 1/4. Okay, it's right above the x-axis. I'm going to do negative 1, 1/2. Negative 1, 1/2. 0, 1 is my next point. 1, comma 2, so 1, 1, 2. And 2, 4. 2, 1, 2, 3, 4. Keep going if I wanted to. If I plug in 3, I get 2 cubed, which gives me 8. Okay, so 1, 2, 3. Excuse me. 1, 2, 3, 4, 5, 6, 7, 8. So my curve looks like this. Okay. So let's look at this line right here. So as my x values approach negative infinity, the y values approach 0. Okay, so negative infinity means as I go further and further left. Okay, so as I'm going further and further left on the x-axis, what's happening to y? Okay, notice my line is getting closer and closer to that x-axis. The other important thing to notice is my y-intercept. Okay, y-intercept right here is the point 0, 1, or we just say the y-intercept is 1. Okay, so there's our first exponential equation. So we've got this exponential equation. We've got a few more characteristics we need to talk about. Okay, so the graph of f of x equals 2 to the x is continuous between and beyond the x values. So our domain is all real numbers. Remember, domain means how far left and how far right. Okay, our graph goes forever both ways. Okay, so we call that all real numbers. Okay, next thing we look at, function gets closer and closer to the x-axis, but it never quite reaches it. Okay, so like how we saw, it just kept getting closer and closer down here. Well, when a function approaches a line in this manner, the line is called an asymptote. Okay, so I get closer and closer to the x-axis, we call it an asymptote. In our case, we're getting closer and closer here. This is a Hoy line, so it's y equals. So we say that our asymptote is y equals 0. So then our range is y is greater than 0. A domain is how far left, how far right. Range just means how low to how high can you go. Okay, so y is greater than 0. Notice my y's are here all the way up. Okay, so domain is all real numbers, range is y is greater than 0. Okay, so let's identify the key features of the function f of x equals b to the x for b equals 2 and b equals 1/2. Well, we already saw what happens when we had 2 to the x, so let's just concentrate on y equals 1/2 to the x. So let's make a table. And we'll go -2 to +2. Okay, and I'm looking at the equation y equals 1/2 to the x. Let's start plugging numbers in. Okay, I want to do 1/2 to the -2. Okay, I could distribute that. -1 to the -2 over 2 to the -2. Okay, remember we don't like negative exponents, so the 2 squared comes up top, 1 squared on the bottom. 2 squared is 4, 1 squared is 1, so it's just 4. Okay, do the same thing with the -1. 1/2 to the -1 is 1 to the -1 over 2 to the -1. And they're going to flip spots because we don't like negative exponents. So I just get this point 2. Okay, let's do 0. 1/2 to the 0. Anything to the 0, just 1. Okay, 1/2 to the first. That's just 1/2. And then 1/2 squared. 1/2 times 1/2, which equals 1/4. Okay, so here's my points. Let's graph them. Okay, so my first point, I'll do them all in blue, was -2, 4. So 1, 2, 1, 2, 3, 4. Next point was -1, 2. So -1, 1, 2. 0, 1. 1, 1/2. Right here. 2, 1/4. About right here. If I connect these dots, okay, my graph looks like that. So some of the things we're interested in is my domain. So how far left can I go? And notice I can go forever. And my right, I can also go to forever. So we say all real numbers. Okay, then we talk about the range. Remember, how low can we go to how high? Graph stops right here, and it keeps going up. So y is greater than 0. The other thing we're interested in is the asymptote. Okay, what line do I get closer and closer to? Well, I'm getting closer and closer to here. So remember, that's a Hoyle line. So y equals 0. Okay, those are the characteristics that are good to know. Another thing you can also jot down is the y-intercept. Where do I cross the y-axis? Right here at 1. Characteristics. All right, so let's look at a word problem. So a network administrator uses the function f of x equals 5 to the x to model the number of computers a virus spreads to after x hours. If there are 1,000 computers on the network, about how many hours will it take for the virus to spread to the entire network? So step 1, we want to make a table. Okay, remember my equation is y equals 5 to the x. Okay, you can use your calculator here to help you. We are going to plug in each of these numbers. 5 to the 0, 5 to anything is 1. 5 to the first is just 5. 5 squared, hopefully you know that, 25. Okay, calculator work, 5 cubed, 5 times 5 times 5, 125. 5 to the fourth, again, multiply by 5, 625. 5 to the fifth, 3,125. Okay, so I want to know when I get to 1,000. Well, I don't get a whole clear number, but it's somewhere in between hour 4 and hour 5. So let's put all of this on a graph. Okay, they did that right here for us. Okay, and it looks like it's somewhere up in here. So take a guess. What does that point look like to you? Well, it's less than half. Okay, so maybe 4.3-ish. Okay, when you've made a guess, really easy, plug it back into your equation. Okay, plug in your calculator 5 caret 4.3, and we get a number that's pretty darn close to 1,000. So it's going to take about 4.3 hours for this virus to spread everywhere. Okay, so try it here. You want to know this time instead of 1,000 computers, we want to know about 50,000. Okay, pause the video a minute, check that out. Okay, well, hopefully you've tried that. If I come back, we did all the way down to 5 on the last slide, and that didn't help us. So let's try 6, 7, 8, 9, 10, whatever you need to. Remember, we're doing y equals 5 to the x. Okay, so let's try 5 to the 6th power. Okay, I'm going to pull up my calculator. 5 caret 6, I get 15,625. So 15,625. Okay, not to 50 yet. Okay, so let's do 5 to the 7th. 5 caret 7, 78,125. Okay, 5 to the 8th. Oh, we're closer. 390, 625. 390, 625. Okay, try 9. Ah, we did it. 1,953,000. 1,953,125. 1,953,125. So obviously 50,000 falls somewhere between here. So somewhere between hours 8 and 9. Pick a decimal. I'm good if you tell me between hours 8 and 9. Okay, so that leads us into how to actually come up with one of these equations. So exponential function is the product of an initial amount and a constant ratio raised to a power. Exponentials of functions are modeled using f of x equals a times b to the x, where a can't be 0, b has to be greater than 0, and b can't equal 1. Okay, so this is very important. You need to know this formula, and you need to know what a and b stand for. Okay, again, a is our initial amount, b is the constant ratio. So let's see how to use this equation. So we're going to write an equation based on this table. So remember, exponential function y equals a times b to the x. So a was our initial amount, so we need to figure out our initial amount. Initial amount is just a y-intercept. Oh, so right here, this is a. Now b is the constant ratio. Constant ratio just says, how do I get from one y to the next? So how do I get from 4 to 3? Well, times 3. 12 to 36, times 3. 36 to 108, times 3. And 108 to 324, again, times 3. So this is b. So to put it all together, y equals a is our initial amount, 4, times b is 3. So my equation is 4 times 3 to the x. Now you need to be careful here. You cannot multiply the 4 times the 3. Remember, order of operations, PEMDAS. Exponents come before multiplication. Because 3 has the exponent on it, you're not allowed to multiply. So my final answer is this. You could also write it as 4 parentheses 3 to the x if you so wish. I'm good with either way. Okay, so table, let's look at a graph. Okay, on this graph, notice they actually gave us the points. Wasn't that nice of them? So same thing applies. I need to figure out what a is, and I need to figure out what b is. So again, a is my y-intercept. So right here, this is a. Now you should be asking yourself, okay, how do I get from 128 to 64? Well, times by half. 64 to 32, times by half. 32 to 16, times by half. 16 to 8, times a half. So what do you think b is? Absolutely. B is 1/2. So my equation, y equals a, so 128, times b, which is 1/2, to the x. And there's your equation. Okay, your turn. Please pause the video and try these problems. I will give you the answer in just a second. Again, remember y equals a, b to the x. Okay, initial value right here, a. Okay, how do I get from 3 to 12? Times 4, times 4, okay, times 4 the whole time. So my equation here, y equals 3 times 12 to the x. Okay, pause the video, try the next one. Okay, so again, a is pretty easy to pick out. That's a. How do I get from 2187 to 729? I'm going to take 2187, divide by 729. Looks like we're dividing by 3. So the way we do that is we times by a third. Okay, times by a third. So my equation here is simply y equals 2187 times 1/3 to the x. Right, so now we know a little bit about exponential functions. Let's compare it linear and exponential. Okay, Teachers offered 2 pledge options for donating to a charity. Which option will increase the pledge amount faster over time? Okay, so we want to know which option is better, which one makes more money. So option A, we get $100 the first week, and each week after that, the amount increases by $25. Option B, we get $1 for the first week, and each week after that, the amount triples. Well, let's work them out and see what happens. Okay, option A, $100 for the first week. So week 0, I get $100. Okay, then after that, I increase it by $25. So week 1, 125. Increase by 25 again, 150. 175, keep increasing by that 25, 200, 225. Do you think that is more exponential or linear? Well, looking at it, I'm just adding constantly, so this makes it a linear equation. Okay, so it's a constant increase, it has an initial value, so this is linear. Okay, I know this is a linear equation. We can do y equals mx plus b. So my y-intercept was 0, was 100, and I got more by 25x. Okay, so my equation would be 25x plus 100. Let's talk about option B. Now, first week, I'm only going to get $1. Ugh, that's not very good. After that, I triple. So I get $3 next week. 9 the week after. 27, 81, 243. Ooh, look at that. By week 5, we're making more money. And it's just going to keep increasing after week 5. Okay, so notice here, we had initial value. Since I'm multiplying by the same thing, I have a constant ratio. So this example is our exponential function. Again, y equals a b to the x. So my initial value was 1 times b was 3 to the x. Which one is better? Okay, hopefully you should absolutely be saying exponential is better. Okay, even though exponential starts out slow, it is always better in the long run. Okay, let's try it. Identify each function as linear or exponential and explain. Please take a minute, pause the video, and think through these 2 examples. Okay, so part A. F of x equals the number of branches at level x in a tree diagram, where each branch extends into 4 branches. Okay, so this one might be helpful to draw a picture. Okay, at first level, I have 1, 2, 3, 4 branches. Then the next level, off of these, I each get 4 more. And I'm running out of room already. And then 4 more here. Okay, does that look linear or exponential to you? We should be saying exponential. It is times 4 each time. Okay, look at example B. Number of boxes in a row X of a stack in which each row increases by 2. Okay, so if I got a stack of boxes, okay, I got 1 box, now all of a sudden I've got 2 boxes. Okay, I got 2 boxes, but it increases by 2, so I add another 2. Oh, and adding each time. So this has to be linear, okay, because I'm adding 2 each time. Okay, so tell the difference. Exponential, you're multiplying by something. Linear, you're adding something. Okay, so that's all I've got for you today. Homework tonight, please look on page 229 in your textbook. You're going to do problems 9, 11, 17 through 23 odd, and 24 through 26. Please let me know if you have any questions, and I'll do my best to answer them. Hope you guys have a fantastic day. Talk to you guys later.